Welcome to another episode of 3-minute videos with Nathaniel. Today, we'll now solve question 1D of MET Oxford 2019. Suppose there are two curves. These curves and the area bounded between them have the area bounded has an area of 9. So we write that number here, 9. Find the possible values of A. We can assure that A can be positive or negative, so let's put on the positive case first. Now, first we'll find the intersections. We bring the like terms together because since there are A's on both sides, we can discard them. So this minus can be turned into a plus. 2x squared plus 2ax equals to 0. Since it's 0, we can take off both 2's. It's called a method of simplification. We can factorize it into x, and x plus a equals to 0. Now, in order for this equation to be 0, either one of these brackets must equal 0. Obviously, the x at the left must always be equal to 0, and x plus a equals to 0. X equals to minus a. To find the area, how do we do it? By using a technique in calculus. I know some of you may have heard of calculus and you think it's very frightening, but no. In this question, we'll see how calculus and this branch called integration will be used to solve this problem. The integration sign looks like a long S, and if anyone all you knows the International Phonetic Alphabet, some of you might know this sign. It's like the SH sound in shoe or shine or shit or whatever this is. So we'll put the lower and upper bounds. Since we already found out what is this minus this, we can put in 2x squared plus 2ax dx. Now you might be asking, why have you not simplified it? Because if you took away both 2's, then the area would be half. Now let's work out this integration. How do we work out this integration? First, we put the powers by 1, multiply by any constant terms, and take away this 3, and then bring it on below the constant term. And since 2 divided by 2 is 1, we just leave it be. Then we solve it. Note that minus a squared is the same as a squared. So we'll put it here. Note that I missed out the 0 because any polynomial term without the constants is always equal to 0 when x is 0. Now let us simplify this. Minus, so let's do the term in the brackets first. Remember what I told you about this? Equals to minus 1/3 a cubed equals to minus 1/3 a cubed. Now, since a can be positive or negative, we can put 1/3 minus a cubed, and since minus a cubed is the same as minus a cubed, then we can put 1/3 a cubed. 1/3 a cubed equals to 9. We put this plus minus sign here to show us that both cases are possible. 1/3 a cubed equals to plus minus 9. A cubed equals to plus minus 27. And if you know about cube roots, a equals to plus minus 3, which is option B. These are two quadratics. How do we solve them, the area between them? We just use a few clever techniques to find the intersection points, a little bit of integration, and finding the values of A. See you in the next episode. Bye!